Hello everyone, welcome to first law of thermodynamics, work done in different processes. Now let's start with isobaric. Now for the isobaric, we know that the pressure is constant and the work done is V1 to V2 pdV. Now since pressure is constant, it can go outside, and then the integration of dV is just V, so this equals to PV V2 V1. Therefore the work done in this case is pressure V2 minus V1. Now for isochoric. So here work done is equals to V1 V2 pdV. Now for isochoric, dV equals to 0. So if this is 0, then there is no work done. Now for isothermal part. Now for the isothermal part, we again have work done equals to integration of V1 V2 by pdV. Now these are both variables, but we can use the ideal gas equation to help us out. So here, if we have 1 mole of substance, let's not take 1 mole, let's just take n mole of substance, right? N mole. Then we have from ideal gas equation, PV equals to nRT. Now here, that means that pressure is equals to nRT by V. So let's just use that right there. The work done is equals to V1 to V2 nRT by V. So nRT by V dV. Now in this case, N is constant, R is constant, and also temperature is constant because it is isothermal process. So work done is equals to nRT. This becomes the nRT goes outside. Integration of dV by V is just ln V. So this becomes ln V V2 to V1. Now let's just do some math right here. This becomes ln V2 minus ln V1. So here, using log property, this is just ln V2 by V1. So in fact the work done is nRT ln V2 by V1. Now here, isothermal process, so that means temperature is constant. And don't forget, in 11th grade chemistry, Boyle's law. If temperature is constant, pressure is directly proportional to volume. 1 by volume, or the both cases. So we get PV is equals to a constant, right? If we let's say this is K, that means P1 V1 equals to P2 V2. That means V2 by V1 equals to P1 by P2. Therefore, work done can also be written in the terms of pressure as P1 by P2. Now this should be the third process. Now for the first process, we have adiabatic process. Now in the last video, I had done the adiabatic equation for, adiabatic process, which is called the adiabatic gas equation, or simply the adiabatic equation. So here, fourth process is adiabatic. Now I'll just write the equations we have learned, which is PV gamma equals to constant, meaning P1 V1 gamma equals to P2 V2 gamma, which is equals to the constant, right? So now work done is equals to V1 to V2 P dV. Now from here we can get the pressure part. So this is equals to V1 to V2. P can be written as K by V gamma dV. K goes outside, and here V to the power gamma comes outside as V to the power minus gamma. V to the power negative gamma dV. Now we can simply use the power rule, which is minus gamma plus 1. by minus gamma plus 1, right? So here I'll just write it as 1 minus gamma and v2 to the power 1 minus gamma going from v2 to v1. So work done is k 1 minus gamma bracket v2 1 minus gamma minus v1 1 minus gamma, right? Now here we can multiply the constant inside. I'll tell you why we'll do that. So we get 1 minus gamma k v2 1 minus gamma minus k v1 1 minus gamma. Now here we can use this one, p1 v1 gamma equals p2 v2 gamma equals to k. Now for, well, we have v2, so let's use p2 v2 into v2 1 minus gamma minus p1 v1 into v1 1 minus gamma. So this is equals to, well, v2 to the power 1 into 1 minus gamma, right? Oh sorry, this should be gamma. This would also be gamma. So here this just becomes v2 to the power of 1. So this is 1 minus gamma p2 v2 minus p1 v1. That is the work done in adiabatic process. Now if you want in terms of temperature, well, we simply have p1, I'll write it here, p1 v1 equals to nr, well, if you're talking about 1 mole, in this case let's say equals to RT1 and p2 v2 equals to RT2. So here we can just write it as, well, let's take R common, T2 minus T1. Quick math. Now these are the works done in different processes. Now I'll talk about the limitations in a future video, which will be a very short video. Thank you.